Hey everyone, today we're going to break down one of the most talked about technologies out there, blockchain. But don't worry, we're going to skip all the confusing jargon. Instead, we're going to look at it through a really simple, really human idea, the promise. So let's dive in. You know, when you really stop and think about it, almost everything is built on promises. The global supply chain that brought you the phone or computer you're watching this on, that's a web of promises. Your car insurance, that's a promise. At the end of the day, our entire world runs on these agreements between people and companies. And that's where things get tricky in the traditional world. All of these agreements depend on us trusting some central group, a bank, a company, a government, to actually do what they said they would. This creates something called counterparty risk, which is just a fancy way of saying there's a real chance the other side just won't hold up their end of the bargain. And, well, history is absolutely full of examples. I mean, just look at the 2008 financial crisis. Talk about a catastrophic failure of promises. You had these huge, centralized financial institutions making all sorts of shady backroom deals. They completely shattered their promise to manage the economy responsibly, and because nobody could see what was happening, the whole thing came crashing down.
Or let's take something a lot less serious, but just as revealing, the McDonald's Monopoly game. The promise was simple: everyone has a fair shot to win. But because the whole game was controlled by one central company, an insider was able to rig the entire system and steal millions. The promise was broken because one guy with special access could just change the outcome.
And this isn't ancient history, right? Remember the GameStop frenzy? The trading app Robinhood basically broke its core promise of fair market access. Because they're a centralized company, they could literally just flip a switch and stop people from trading, protecting their own interests and leaving regular users completely out in the cold. So you see the pattern here, right? In every single one of these stories, the failure happened because we had to trust a central party who could bend or just straight up break the rules. So it makes you wonder, what if we could make an agreement that was guaranteed to run exactly as written, with zero possibility for human tampering? And that, right there, is the whole purpose of a smart contract. It's really just an agreement, but instead of being written on paper, it's written in computer code. The absolute best way to think about it is like a digital vending machine. You put your money in, that's the data or the value, and the machine is programmed to automatically spit out your snack. There's no person in the middle deciding if they feel like giving you your chips. The code just runs.
So what gives these smart contracts their superpowers? Well, they run on a blockchain, which gives them three incredible properties. These are the three pillars that let us build agreements that don't rely on trust at all.
Okay, first up, immutability. This means that once a smart contract is put on the blockchain, its code can never ever be changed. This is so crucial. If that McDonald's lottery had been a smart contract, it would have been physically impossible for that insider to rig it. The rules are literally set in stone, or, in code.
Number 2, decentralization. The contract isn't running on one company's computer. It's running on a global network of thousands of computers all at once. And what that means is there's no central off switch. A company like Robinhood couldn't just decide to shut it down because no single person or company is in control. And finally, number 3 is transparency. The code for these smart contracts is usually public. Anyone can go and check the rules of the game before they decide to play. This completely gets rid of those hidden, backroom deals that caused the 2008 crisis. You can see for yourself if it's fair.
So what this all boils down to is a massive shift in how we think about trust. We're moving away from a world of brand-based trust, where you trust a company's logo and reputation, to a world of math-based trust. You don't have to trust the people behind the curtain, you can just trust the code itself, which anyone can verify. Okay, so this all sounds amazing, right? Unbreakable promises. But, of course, it's not that simple. As more and more people started using these powerful tools on a single blockchain like Ethereum, a whole new problem popped up. The network got totally jammed. It's like a single highway leading into a massive city during rush hour, just complete gridlock. And wow, this chart really puts it into perspective. Bitcoin can handle, maybe 7 transactions a second? Ethereum does a little better at 15. Now compare that to a regular payment network like Visa, which handles thousands. This kind of congestion means slow transactions and crazy high fees, which makes it totally impractical for most people to use every day. So how do we fix this traffic jam? Well, you build more roads, and that's happening in 2 main ways. On one hand, you have what are called layer 1s.
Think of these as building brand new separate highways from scratch, blockchains like Solana or Avalanche. On the other hand, you have layer 2s, which are more like adding express lanes on top of an existing highway, like Ethereum. They process transactions super fast and cheap, and then settle the final results back on that main, secure road.
But let's be real for a second. While all this potential is incredibly exciting, this technology is far from perfect. It still faces some really significant hurdles and totally valid criticisms that people are working hard to solve right now. We're going to look at the three big ones: security risks and scams, which are obviously a huge worry for anyone using the stuff, energy consumption, which has been a massive topic of debate, and, kind of ironically, the constant pressure towards centralization in a system that's designed to be the exact opposite. Security is a massive deal. I mean, look at that number. Over $2 billion stolen from crypto-related hacks in 2022 alone. That's staggering. But it's really important to understand that most of these hacks are failures of the apps built on top of the blockchain, or they're collapses of centralized companies like FTX. It's usually not a failure of the core blockchain tech itself, which honestly just makes the case for decentralization even stronger. Now, let's talk about energy, because this has been a huge, huge criticism. The original model that Bitcoin uses, called proof of work, is incredibly energy hungry, but there's been amazing progress here. In 2022, Ethereum went through a massive upgrade called the merge, switching to a new model called proof of stake. And the result? This one change cut Ethereum's energy use by over 99.95%. It proves that the industry can and is innovating to solve its biggest problems.
And the last one is a bit ironic, actually: centralization. It turns out that whether it's through mining or staking, there's a natural pull for power to gather in these large pools where lots of small players combine their resources. The risk is that if just a few of these pools get big enough to control a majority of the network, you're right back to having a central point of failure, the very thing this technology was meant to avoid. It's a really critical, ongoing debate.
So, after all that, where does it leave us? We're really at a fork in the road. We're moving from a world that for centuries has been built on promises backed by reputation to a new world where promises can be backed by verifiable math. The technology is absolutely still growing up, and it's got real challenges to figure out. But the fundamental choice it's giving us is pretty clear. Will our future systems rely on trusting people or trusting code? The answer to that is going to shape just about everything.